application example how one can determine the bonding strength of titanium nanoparticle coated film on various substrates. Several parameters can be determined using LUM instruments, as you will see on the next slides. Even the LUMiSizer instrument being used to define some scientific opinion of the European Commission on titania-based products. Will be finished products as well as titania containing coatings. This allows for different access points for the instrumentation provided by LUM. Whether we characterize powder, we have two instruments. When we come to the characterization of slurries and suspensions, there's a broader range of instruments applicable depending on the particular needs. And for the coatings, we have the right part of the picture where we can see the X-ray transmission on the x-axis depending on the position of the y-axis. Here we have for aluminum oxide the highest transmission, higher than 90%, due to the low attenuation coefficient. The middle fraction consists of calcium carbonate. Here we have less X-ray transmission, about 20%, and having the highest attenuation coefficient, the top layer of titania resulted in only a few percent of X-ray transmission. The higher the linear attenuation coefficient, the lower the X-ray transmission. If we use a very, very small 100 nanometer filter, we can see there are almost no more particles in fraction 1, neither in fraction 2. We count only 140 titania particles in fraction 1 and 54 particles in fraction 2. Single particle counting was successfully performed in the LUMiSpock instrument. We have here counting and particle size applied for the characterization of first titania particles, because, for example, different surface coatings may have different interactions with the same filter size media. We have seen a clear difference between cellulose and nylon, having the same nominal size. And second, of course, we can characterize the filter media and their efficiency for titania filtration as well as for any other kind of particle filtration. Jumping to slurries and dispersions in their original concentration. Depending on the properties of the slurry and the time we have, we can either use LUMiReader PSA with near-infrared detection, or we can use X-ray detection in LUMiReader X-ray. Or cheater in testing speed, it's your choice, and we can extrapolate on the sedimentation velocity at gravity, which is 0.47 millimeters per day for sample number 1, which is for sample number 4, 0.95 millimeter per day. This is also in line with our very first impression from the raw data. There are several publications in this context. I would like only to recommend one of my colleagues, 2 and pH4 transmission profiles. We can see by naked eye it's absolutely not very similar. It's not similar at all. It's completely different. We can see to the left at pH 2 a rather colloidal stable system undergoing a polydispersed sedimentation. At pH 4, we see clear indications for a strongly flocculated system undergoing a zone sedimentation and a sediment compression that is not in line with the zeta potential measurements. So we have to say, having a look at the details, having a look into the real sample following the in situ changes, the analytical centrifugation shows the real life of the nano titania. These two instruments have two independent views on each titania. We have the stability look onto the titania formulation in the original concentration, and we might have the particle size distribution look onto the titania under the applied particle size distribution measurement conditions. And the median value of the new product is significantly higher. We can conclude from this, before we may use the new anatars for the identical application as for the benchmarks, we need to process this raw material further. Maybe there's some additional milling required. And here they use the LUM technique and the LUM instrument called LUMiFrac to determine the bonding strength of the map dispersed nanoparticle coated films on several substrates. I don't want to go too much into the details and into the numbers here. You are very much welcome once more to download this article from the internet. Let me summarize. The next step for titania applications could be in the field of dry titania, could be characterizing titania suspensions and slurries by using appropriate LUM instrumentation. Single particle counting is now enabled. Particle size distributions are obtained according to different ISO norms depending on the instrument. Particle density in suspensions can be determined according to another ISO. This was not subject of today, but it's possible. The colloidal state of nanoparticles is directly and reliably characterized, making use of the advantage of analytical centrifugation. Direct real-time and accelerated stability testing under real conditions is applied. Accelerated stability analysis allows for comparative and predictive shelf life analysis according to the technical reports of the ISO. Save your time once you have very stable formulations by applying accelerated stability testing. Sediment characterization allows for deeper understanding, for example, of particle interactions and results from particle surface modifications. And last but not least, in the field of coating characterization, the bonding strength of titania films on substrates is easily determined by another LUM instrument.